So what I want to do is I want to run a sample Wireshark capture and show you around the program a little bit. The labs that we have on Moodle. So here's the PDF for the lab, Wireshark Lab 1 Intro. So that's an introduction to Wireshark, but there's a lot of text to it. Yes, I do want you to read it, but understand when there's 3 pages worth of text, sometimes it's hard to get it all in your head. It's a lot easier to watch someone and hear them talk about it. The second lab is the HTTP lab. So these do different things, but essentially what Wireshark does is packet capture. So we're going to capture packets as they occur on the network and be able to drill down into them and see what's happening. So if I want to start a Wireshark capture, here's what I do. Open up the Wireshark program. Personally, I don't care if you update the program, what it offers, and things like that, because for our purposes, we don't need it. You're going to select off this first menu, local area connection. So it's going to say some variants of what connection do you want to capture from. The other ones that are listed, they're not going to come up with anything because they're virtual connections. We'll talk more about those later on. So you would want to click local area connection and then click start. And when you hit start, you immediately start seeing tons of things come across the screen. So what we're seeing now, I'm going to let it run for a second, we're seeing all the data that's moving across the campus network right now. And you can follow along and do this as well. Let it run for a minute. Then when you hit the stop right here, the red stop, you stop capturing packets. So just in the 20-30 seconds I was talking, I captured over 5,500 packets on the campus network. So the ones that we're seeing are the things that are accessible by the switch that we're all connected to in the back. That switch is connected to the overall wired campus network. So that's what we're seeing as we run this capture. So once we do this, we see a lot of information, tons and tons, and it's all color-coded. So there's lots of different ways you can sort this. You can sort by the sequence, the time, the source. So the source is the computer that this request is coming from. The destination is where it's supposed to be going to. Then the protocol, we'll really get into protocols next week, and we're going to talk about a couple of them today. The length of the packet, and then some info about the packet, and we're going to see some things happening down here. So I'm going to sort by protocol because I want to find some interesting protocols in here.
Can you go back to how you got there?
How I got there?
Yeah.
When I got to the opening screen, I hit local area connection and start. I can't do it again or it's going to redo everything I just did. But that's how I got there to begin with. So here's an example right here. So the source right here, you'll notice that this is in hexadecimal. What kind of address did we talk about that was in hexadecimal?
IPs and max.
Max. Max are in hexadecimal. So this is telling me that this is a Dell manufactured MAC address, right? That's the Dell part. Because remember, the first 3 numbers of that are organizationally unique identifiers, right? And this is the last 3 digits of that MAC address. This is a broadcast. The protocol that's used for broadcasting is called the ARP, or the Address Resolution Protocol. So here is a real live example of someone trying to do a broadcast on a network. So when you look at this, the length of the packet was 60 bytes. Be sure to say that right. Not bits, bytes. So here you see who has this address, tell this address. So this address right here, 10.40.77.25, is looking for this person. So it's going out on the network and saying, if anyone already knows where this is supposed to go, give me that address so I can send a packet to them. And when you go down here, you'll see words that we saw like frame. We talked about frames being something layer 2. So here we're talking about MAC addresses and frames. So we're within layer 2 of the OSI model. And you can look and see, there's lots of things in here that we may not have talked about before, but some things that can be interesting to look at. So here we go. Here's one thing. Destination broadcast. Remember we talked about when we broadcast we use all Fs? So that's where this initial package went, or this packet went out to the broadcast. And here's again our source. Our source was a Dell MAC address through here. And then we see the ARP request, or the address resolution protocol we talked about. So here's our sender MAC address, sender IP, target MAC address, and target IP address. So all that information ran across the network in 0.3 of a second to try to find an IP address for someone else to send data with. So let's look at something else. You can see in here Apple, Light On, another brand. We've got Dell stuff. So just within that very small period of time, there was tons of address resolution that was trying to happen. People saying, okay, I need to send this packet somewhere, but I don't know how to get there. So can someone on the network who already knows tell me, right? When we see these 10 dot addresses, we'll talk a lot about this later, like so much you're sick of it, but that is a private address. That is what the address that the wired computers on our campus network use. So anytime you see a 10 dot, it means it's a computer in a classroom that's wired up, or in the library, or in the internet cafe that's wired into the wall. They all use a 10 dot something address. So let's find something that's not ARP necessarily, although there's just tons of them. Okay, there's some things happening in browsers. There's DHCP. We talked about how MAC addresses come from a higher power, and they can be changed whenever that higher power deems it so, right? So here's an example of that. Here's a DHCP packet. So we can see. Now, what's interesting about this is a packet. So a packet comes at layer 3, right? So you look here, here's the frame part, the layer 2. Here's the layer 3 part, the IP version 4, right? So here we have different things that we can look at. But we still have our destination, our source. We have the port number that things came in and out of. So we have a little bit more information. So depending on the kind of packet and what's inside of it. Now you see all this down here? This right here is the actual what's going through on the packet, the ones and the zeros, right? The binary, we talked about the ASCII characters and how they represent ones and zeros. So what you see down here on this menu is what's actually being transferred when you drill down to the lowest possible point, the actual bits that are moving through the packet. So there's an example of another kind of packet, DHCP. If you've ever heard of ICMP, also commonly called ping, right? So if you try to ping a workstation to see if you can communicate with it, that's what ICMP does, and we'll do that later on as well. So here's another example of just trying to ping something and then determining that they can't, the destination is unreachable. And you can see someone tried to ping this .60 computer over and over and over again. So for whatever reason, that computer's not reachable. So now the troubleshooting begins to try to find out why. So there's some things that we can see as well. SSL, that's someone trying to make a secure connection over the internet. So maybe trying to sign into something, Facebook or their email or something. This is one thing that y'all will use when you actually go to do this. We talked about if the packet is bigger than 1 packet length, you have to have sequencing to it. So you have to say this is packet 1 of 5, 2 of 5, 3 of 5. So they all end up in the right order so they make sense. This is an example of this TCP right here. See, they're going back and forth. So 75 asks for something from 60, and then again, and then 60 sends something to 75. So this is this TCP, we call it a 3-way handshake. This is this handshake in action. And you can see they're sending the sequences of packets and acknowledging back and forth that they've done it. So that's exactly what we talked about in class. Very fortuitous that came up in our capture just now. Lots of TCPs. Mercy. And then we have some packets that are the UDP we talked about being the unreliable protocol. It just gets there in whatever order and it's probably okay. It's kind of the fire and forget. here's our UDP versions of that. So there's people sending out to the broadcast and a couple other places on different source and destination ports. So these are all kind of backing up some of the things that we talked about. And once you actually get into your labs, it'll make a lot more sense. But I just kind of want you to be able to understand, okay, if I'm looking for information down here, if I'm looking for a IP address, I want to look in the IPv4 part, right? And there's my addresses. If I want to look for the MAC address, then I want to look in the frame part. So in this case, it's all Fs, it's a broadcast. So keeping in mind, this is going to be reinforcing the layer 2 and the layer 3 stuff that we talked about, and kind of even the layer 1, because you can see the bits as they actually occur. So I'm going to pass out the OSI model lab. And go ahead and start work on the Wireshark 1 and 2. If you have any questions at all, raise your hand and I will help you. If you're trying to find an address or something and you can't, the labs are really step by step. If you can't find something, please let me know and I will help you. Okay.